Hey guys, welcome to RC Video Reviews. Today we're going to do a little deep dive on redundancy for your radio control setups. And the reason I'm doing this video is because after flying the big plane, I set it up with a battery power supply, not a BEC power supply, just a battery, single power supply. And I really didn't like that because on a BEC, I have a Scorpion in there and I was able to turn it off, but that Scorpion could provide an alternate source of power if necessary, if the battery failed for whatever reason, if I didn't charge it before I took off, for example, and didn't catch it, that type of thing. So it really kind of bothered me. And after flying that day, Dave and I went out, we had a couple drinks, we sat down, had some nachos, and we talked about redundant power because this is what we do. So when we were talking about this, we were looking at, I've done a video on redundancy before, and I'm going to refresh that, right? I'm going to give some new information because things have changed a little bit since then. So what I'm going to do is this is going to be a build, kind of like a build slide. That's what I'm going to go through tonight, is a little bit of a build. And the idea then is to show you step by step how you put this together. So we're going to start with a real simple part, and that's that I've got an ESC and it's connected to my programmer. Your programmer may be different. You may do stick programming or something like that. That's fine. But, all I'm going to do first is set my voltage. So I'm going to set the BEC voltage on this ESC to where I want it to be. So I'm going to hit parameters. That'll load up the profile off of the ESC. And as soon as that's loaded, I'm just going to scroll down and I'm going to look for my BEC voltage right there, and I'm going to set it to 8 volts. Now on this particular BEC, the highest you can go is 8 volts. You can't go to 8.4, which is fine. 8 volts will work. I have other ESCs that will do higher than that, including 8.4. And for those, if I have servos that support it, that's what I'll use. It's really important to understand your power, your voltage requirements on your servos and your radio subsystems. Okay, it's important to understand that. In my case these days, I tend to try and build everything to support 8.4 volts because that lets me use little things like this as a power supply. And I really like LiPo batteries because they're highly reliable and they can deliver the current. So, okay, first step is set your voltage. I'm going to hit save. Now, I already did this, so it's already set at 8, but that's the first step. So now I can get rid of this. We're done with that. And I'm going to disconnect the programming lead. And now I've got just to write, everybody that flies electric, this should be instantaneously familiar to you. It's just an ESC with a battery. That's it. That's all I've got here. And on the back end of the ESC, I've got this simple little wire. Okay, just this wire that comes with the ESC. I'm just going to set this aside because I don't need it. All right, I don't need it anymore. It doesn't need to be in frame. We got a lot to cover, so there's going to be a lot of material here. Now we're going to show you the guest of honor, and you'll have to forgive. It is sloppy soldering. I put this together in a little bit of a hurry. If I were to put this in production, I would do a much better job. Okay, so don't criticize my work. It's just I just stabbed this together out in the garage real quick. But the trick here is the diode, and these are Schottky diodes. Now, if you want to get into the specifications of a Schottky diode, that's fine. But the reason I use these is because they have very low forward voltage drop. All right, that's why we use these, and they can support high amperage. Like this particular model, this is a 90 SQ22, I think. Oh no, it's 040, and this one supports at peak for 8.5 milliseconds up to 400 amps, and the rated pulse amperage is 18 amps. So it's a substantial little diode that can handle the current draw, at least in a backup condition for an airplane. And now I want to also point out that the diodes are marked with these stripes, and that indicates the voltage bias. And in my case, the voltage source comes from this side. Okay, that comes from over here. That's going to get plugged in to my ESC. In fact, we'll just do it. All right, so that's my voltage source. That's where I'm getting the power from. Remember, that's my BEC over there. Okay, and so that this bar is on the opposite side of that source. It goes toward the output of the voltage. So that's a forward bias connection. Okay. Now that's important to remember because what that does is it prevents current from going this direction. And the reason we have to do that, and that's why this little device is the star of the show, is because if we prevent current from traveling from our power side, our load or our redundant system into the ESC, then the ESC can live with that. It can put voltage out. It doesn't take voltage in. Keep in mind, this is not a device that's meant to be charged, right? That's the key. You're not supposed to charge these, all right? You can charge a battery, but you don't charge an ESC. That's why you put the diode in here. It prevents current from flowing in this direction toward the ESC, which would be bad. All right, we don't want that. Okay, so we're doing our build slide, right? We've added, all we did was we took our regular ESC connection, we plugged it, I made an extension, and I put a diode on a Schottky diode on the positive segment, the positive line, with the stripe facing toward the load. Okay, that goes toward the load. All right, that's it. That's it. Super simple. All right, now we're going to get all this. We're going to keep shoving this stuff out of the way that we don't need to see. So now this is our current protected ESC power. Okay, that's what that is. Now it's going to start getting a little bit complicated, but I'm going to bring in this board, this parallel board, and the reason for this is because I'm going to show you how all this stuff comes together. So all I'm going to do now is I have this set of alligator clips connected to the board right here, and I'm going to plug my ESC power in. All right, so we're going to plug that in. Now what we're doing is we're delivering this entire board is in parallel. Okay, so all I've done is added power to this board, and I'm gonna prove that to you. And I do have to zoom out a little bit to get everything in frame. So we're gonna zoom out just a little bit so you guys can see everything. Now I'm gonna put my meter on, so I put it on DC voltage, and I'm just gonna connect my meter to this board now. All right, so there we go. And now you can see I've got my 8 volts coming in. And for those of you who are concerned about voltage drop, the Schottky diodes at lower voltage values, they have very low voltage drop. It's like 0.35 volts, so it's very little. And you can see we configured that ESC to output 8 volts. You saw it happen, and you can see this is a Fluke 87. It's a very good meter, highly accurate meter, and it's showing me 8.12. So I think the ESC is putting out just a little bit higher than the rated value of 8, and that's because with the diode in there, we're going to get a little voltage drop, but I'm still seeing 8.12, so we're good. Okay, so now we've got our BEC putting 8 volts into our parallel system. Okay. Simple. I hope this is all clear so far. It should be pretty straightforward. Now what I'm going to do is I'm going to add a load. All right. This is a little device that I made. I made this some time ago. I made a video on it. This is called Captain Dan. It's just a couple of resistors in parallel and surrounded by some fans. And the cool thing about this is I can use this to generate a load anytime I want. So I'm going to just drop this in my board, and you'll see what will happen. That fan does not start spinning because my voltage dropped all the way down, and I'm not sure why that happened. Live streams. All right, I'll tell you what, we'll come back to that in just a minute. The next thing I'm going to plug in is a battery. So this is now, we're going to pretend this is my secondary power source. All right, secondary power. I'm really disturbed that that BEC didn't supply the voltage I need there, or the current I need to spin this. Anyway, this is my secondary battery. All right. So imagine this I shouldn't say secondary battery. This would be the primary power source. Okay. The primary power source. So we're going to plug this into our circuit here. But before I do, there's a rule here. And that rule is that your BEC is putting out 8 volts. We want to see our battery being somewhat close to that value. So you can see I've got 7.8 volts right there, 3.9 volts per cell. So you don't want to have a big disparity here. It's really important not to do that, because what will end up happening is the ESC, what will happen is it'll dump current into this battery at its highest rated value. So if you have a 10 amp ESC, for example, a BEC, and it has the ability of dumping 10 amps, then you're going to charge a 1500 milliamp battery at 10 amps. Okay, we don't want to do that. So what we will do, though, is I'm going to take my current meter, because I want to show you that this is safe to do. And I'm going to set my current meter to DC, and I'm going to put it around the negative line on the battery, and I'm going to leave my cell meter attached. Okay, so I know that's a little convoluted, but that's the way it goes. All right, so I'm going to now connect the battery to this parallel circuit, and you'll see right away that we got equalization right away. See how this is at 7.8 and now the meter is showing me 7.8 on the BEC. All right, so 7.8 here, 7.8 here. And if we look at the current, it's 0.25. So what's happening right now is that the voltage is, the higher voltage is coming into the battery, and we're applying a very small amount of current to that battery. And what will happen is when they reach peak, it'll just stop. It'll equalize at, it's about voltage potential. So if you have 8.8 volts here and 8 volts here, that voltage potential is equal, so there's no movement. One does not feed the other at that point in time, okay? Doesn't feed the other. Now I'm going to take my load and add the load, and when we do that, there we go. You can see Captain Dan is spinning now, and you can see the amperage coming off the battery, right? So the current is coming off the battery right now, 2.2 amps off the battery. And what's happening right now is that they will just maintain this equilibrium. So even though we're providing current from the battery, the BEC will wind up charging this battery. So when you get done with your flight, you should come down with the same voltage you went up on, that you went up with, okay? Now, theoretically, I should be able to disconnect my battery from the circuit, and that fan should keep going. I'm not sure why that's happening. Something is amiss. It worked earlier. I don't think I'm going to try and troubleshoot it here, but that should keep going. Like I don't know exactly what's going on there, but when I did my testing earlier, that kept operating, because what should be going on right now is this BEC should be feeding the load, and I'm just not sure why it's not doing it. but earlier when I tested it, it did. Maybe it's just, I guess it's, you know what we can do? We can put something on here and just see. I'm going to put the current meter on and see if there's any current going in there. Yeah, it's 0.3 amps. So I guess the load's just not high enough. It's just not high enough, I reckon, to pull. But it's pulling 0.2 amps. So I think the fan is just not getting enough to spin. But we are getting a small current draw on there. So it's still there. It still exists. So that's a redundant setup, okay? Now that was a build slide to show you we take our ESC power and connect that to our load. Then we take our battery and connect it to the load. And then what'll end up happening is it's not a problem doing that, because boy, I really cannot explain why that's not spinning with that BEC. It kind of makes me wonder if something's wrong with my BEC almost, because it's dropping. If you notice when I take the battery off, it's dropping right down. Whoops. It's dropping right down to 0 volts right away. It's almost like it's treating it as a short or something. So I'm not sure. Anyway, that's disappointing. So, okay, back to the story. The ESC and the battery voltage are at equilibrium, 3.77 here, 3.75 here on the board. So everybody's happy. Battery's being charged only up to the peak voltage, and you'll come down with a battery that's charged. And if my setup were working correctly, when you switch power systems, it just automatically fails over. Like it never even sees a blip. Now, I want to cover a couple rules for you real quick. If you're using, now the example I showed is a BEC and a battery. So if you do that, remember you got to put a diode on your BEC, and your battery peak must be at or under the Beck voltage. So the BEC voltage in my case is 8 volts, right? 8 volts. And the battery there must be at or under that. So I'm not going to, the reason you don't want to put an 4.2 times 2, this is a 2-cell battery, that would be 8.4 volts, is because if you do that, then you're going to be trying to test the Schottky diode. The good news is the diode won't let the current come in, so it won't really matter. But there's no reason to do it. So if you have an 8-volt BEC, just set your battery voltage at 8 volt when you take off, and you're fine. What you really don't want to do is get really higher voltage levels on your battery. And then finally, your battery voltage should be less. Any battery voltage less than BEC voltage is okay, as long as it's not huge. So like if your BEC voltage is 8 and your battery is 7.7, that's fine. That's fine. Because what will happen is the BEC will charge. Just keep in mind, it'll charge if there's a significant discrepancy. Like if you're at, say, if you plug in a 3.3 volt battery and the BEC sees that, it's going to try and dump 8.4 volts in at its highest amperage capability. Okay. So the BEC will charge your battery to peak voltage and the highest, by the highest current supported by the BEC. That's the important part. Okay, if you use a BEC and a BEC, you can do that. So if you don't want to use a battery, instead you'd rather use 2 BECs. So if you don't want to use a battery, you can do that. Just remember, if you do that, BECs aren't intended to be charged, so you have to put a diode on both BECs, okay? Very simple, very simple. All right, now what I want to do next is I want to go back to the overhead here and show you guys, let's do this in a practical sense. So I'm gonna disconnect this for the moment. We'll get rid of the meter, and I'm gonna show you the configuration as if it were going to be on your model. So we're gonna get rid of the board. Whoops, I'm gonna get rid of the meter for the moment. And I'm going to bring in an example that I use, the power distribution system that I use, these little Builda PDBs, okay? So in this case, the way you'd wire this in your plane, we'll get rid of the meter. And all we're going to do here is connect this is the way I would do it in the airplane, right? I'd connect the battery to the PDB. And when I do that, assuming I plug things in the right way, like this, we get power to the receiver, okay? So this is a line that goes, say the throttle channel is number 3. That goes to my receiver channel number 3. That's the one I use for throttle. You can use whatever you want with EdgeTX, but in my case, I'll use channel 3. Now what I can do is, remember, this is my BEC. I can take this and plug it in on this side on channel 3. And when I do that, now what happens is I've got power. This is the practical application in your airplane, okay? I've got power coming in from the battery, feeding the circuit, and I've got power coming in from my BEC, feeding the circuit. And they're both at that equilibrium value of 7.7 volts. And as a result, we're allowed to do that. No problems with the battery. I'm going to get getting a couple of probes out so we can put the meter on here real quick and just take a look for you guys, just to show you. So this would be an in-plane setup. This is not like a bench. Like, this is how I would actually wire it in the plane. So we'll set that to DC, and let's see, it's power here in the middle. Let's see if I can do this without moving the board. There's power in the middle. And then, let's see, you guys can see the meter. Okay, there's ground. Oh, that's signal. Switch sides. There's ground. So 7.7 volts, right? There we go. And we've got 2 power sources going in there, right? We've got our BEC power source going in, and we've got our battery power source going in. And the thing that makes this possible is this little diode, these little Schottky diodes. That's what makes them possible. And they're like 50 cents. So all you have to do, if you want to add redundancy, you can do it with a battery system like this, or if you want, you can use another BEC. So if you don't want to use a battery, and say you just wanted to use a real simple setup like this, like, we'll get rid of all that other stuff and we'll just plug, this is normal, like normal smaller planes. We would set them up like this, right? See, it's got power. I don't know why it's struggling with the fan. Anyway, you could take your ESC and plug it into your receiver just like this. Take a diode. Solder it on your positive lead, right? Forward bias, so the stripe going out. And then just take another one of these connectors, solder it on there, and plug it into, say, the battery port on your receiver. Now, with very, very little effort, you're talking 1 extra BEC, right? And well, actually, I have this backwards. This goes on your mains. Sorry, these go to your mains, and this wire would go into your receiver, right? So you solder the red in, just in line, just like I did on this one. Same deal, just like that, with the forward BIOS, the stripe going out. Plug that into your receiver, and then this BEC will also act as a power source. So the thing that makes all this possible is this little Schottky diode, because it's preventing devices that aren't supposed to be charged from being charged, right? It limits the current, it stops the current from going into that device. And that's what makes it possible. The other key, and this had to do with my conversation with Dave, the important aspect here is that LiPos, keep this in mind. Your LiPos are 8.4 8.4 volts per cell at peak. Okay. So if you've got an 8.4 volt BEC, then you can charge this to peak, plug it in, and fly all day long, knowing that the BEC is charging it's kind of like trickle charging your LiPo while you fly. And your LiPo is providing the current for your system while you're flying. And that's a nice, safe outcome, especially on a bigger plane, you know, like the ARS or that Avanti. We did the Avanti. It's good to have redundant power in a situation like that, which I do. The Avanti does have redundant power. And of course, you know, in this model, we'll have, I'll be adding, all I have to do to turn it on is I have to go back to my BEC settings on the ESC and turn the voltage back on, and then plug this in line in between my throttle, where my throttle plugs into my Builda PDB right now. So the throttle comes in on the power side, the BEC side. So that's all I have to do is just put this in line in between the throttle that's currently there, turn that in, plug that in the throttle line, and then turn on the voltage at 8.4. And then I'll have a fully redundant power system for my ARS, my 102-inch ARS. Okay. I'm checking comments. Can you measure the voltage drop on the diode? Yes. Actually, I did, and I didn't see it. So Rambo Flight Ken says, hey, can you measure the voltage drop on a diode? Yeah, we can. Let's do that. I've still got the BEC plugged in. And we'll take a measurement. It's very minor. I'm not even sure if it'll be picked up, but so if we take, he wants the voltage drop on the diode. So if we take a voltage, we'll do ground up here, and voltage here, and we're seeing 8.15 on the power side, and we're looking at 8.14 on the anode side. So it's minuscule. In fact, I'll even show you. I have the data sheet, so let me bring up the data sheet and we'll take a look. So the data sheet is right here, and you can see the voltage drop where here forward voltage drop is maximum at 9 amps, maximum 0.48. And of course, under load, there's nothing. And for whatever reason, maybe I should try putting that load on one more time. I'm really annoyed that load didn't work because I have no idea why it didn't. It worked earlier. So I'm really kind of annoyed about that. I got to be honest. That's the problem with live streams. You can't really sit here and try and figure it out. But it definitely should work. There's no reason it shouldn't work. Because the BEC has got plenty of power for it. No doubt about that. Okay. So if you put it under load, I'll get the meter plug back in real quick so we can see what's going on here with the voltage. Okay, so I'm going to take this off again, and we'll plug in our BEC again. And I might try a different battery just for the hell of it. Okay, there's 8.14 volts. This should work. Oh, look. See, it's working now. See that? I don't know what the heck I did that was different. There, it's working now. Okay, fine. I'm going to show you guys because it really annoyed me that it didn't work. Okay, now I'm going to plug my battery in. There. I'm going to put my current meter back on. Dang it. Stupid live streams. All right. So here we go. I'm seeing negative current here. So I think that means the draw is coming off of it's negative current. So that means it's got to be coming off the battery, right? So if I switch it to the positive line, I'm not sure. I'm not an electrician. I'm not sure what exactly that's telling me. I'm seeing 1.6 amps, 1.7 amps. But we're definitely seeing some current flow now. Now, in theory, if I take the battery off, see, it's working. That's what I was trying to show earlier. Now, if I put this back on and we take the BEC power off, that's this one, it still works. That's what I was trying to show. That I don't know why that didn't work earlier. I'm gonna have to watch a video and see what the heck I missed. Maybe something was shorted. I don't know. I really don't know. But if I plug that back in, now I should be able to take the battery off. Ta-da! there it works. All right. Anyway, let's see what's going on here with the current. That's negative on the positives, on the positive lead. So I'm seeing 0.8 amps on the negative. So that should tell me that I should have about the same thing over here. No, that's 2 amps. So the load, in this case, I'd say the load is definitely coming from the BEC. That's what's supplying the current. But if I plug this in, plug the battery in, for some reason my meter turned off. So I'm seeing negative 1 amp there. Now, if I take the BEC off, let's see, I'll just disconnect the BEC here. Still seeing negative 1 amp. So that means the power is definitely coming from the battery. I'm not sure why it's reading. Oh, maybe it's just the underline. I'm not sure. What happens if I put it on the red line? Now it's saying 2 amps. So 2 amps is the reading I'm getting from the battery. If I plug the ESC back in, does that switch? No, it doesn't switch, but it's lowered. So it looks like they're both supplying current. That's what's going on. They're definitely both supplying current because that dropped from 2.2 or whatever down to 1.7. So they're both supplying current to this fan. But there we go. That's the idea. There's your redundant power. So take the fan off or take the battery off. Fan still works. Great. We take the ESC off. Fan still works. Great. Everything's perfect. So there's your redundant power. I'm glad we got that to work on the live stream because I'm telling you, that's how it worked before when I did the test. So let's see. Robert says, "One job, John." I know, right? I tell you, it's just, it had to be a short, man. Something in here must have been touching that wasn't supposed to be touching. I really don't know. Maybe one of these things is bad. Could be. I'm not sure. Kids and cats and live streams. Thanks, John. Good lesson. Thanks, Wayne. Appreciate that. So there you go, guys. Little simple. Like these things are like, I don't know. They're like 50 cents. They're really cheap. You can get them. You can get them. Oh, you know what? That reminds me. He asked about the voltage drop. And I said, yeah, let's put a load on it. So let's check it with the load. Yeah. Let's just check it with the load real quick. Because, and I still think it's going to be trivial, to be perfectly honest with you. I just think it's going to be very trivial. Okay, so the good news is, okay, so we can just plug in down here at the bottom and get the current, get the voltage as it sits. So we're seeing, maybe that's not a great idea. Let's do it as close to the device as we can so we don't suffer resistance losses in this little board setup that I have, which is not indicative of what you do when you fly. Okay, so I'm going to take a voltage reading on the power side of the diode. So here's that. And come on. I don't know why it's not reading. Let's try this again. Okay, 8 volts on the ESC side, and on the other side, 7.69. So yeah, there it is. It's about 0.3 volts. That's the voltage drop, 0.3. Right? So there's 7.7, and on the ESC side, we've got 8. And that's with a 2 amp load. Okay? So there you go. That answers that question. You are going to get some voltage drop. That's known, right? That's known. But it's not much. And that's why we choose the Schottky diodes. That's why we go with those, because the voltage drop is small. It's a very small amount to pay for, it's a small penalty to pay to have this type of system in place. So there you go, guys. That's really everything I wanted to show you. I'm glad this stupid fan started working this time. That makes me feel better, like we accomplished something. See, that's what it's supposed to do. It's still running, which is great. All right, that wraps up the video. I'll get on Discord if you guys have questions on Discord. Oh, well, let's see. Dan says, will this work on dual BEC, ESC, and a twin? Yeah, that's exactly the point. Yep, exactly. If you want to use dual BECs, just remember the rules, right? Let's go back to the rules real quick. The rule is if you use dual BECs, you have to have a diode on both BECs, okay? So just like the main one that I have here, this one right there, that's the main BEC. You'd also have to put a BEC in line, or sorry, a diode in line on your other BEC as well. Remember, the whole objective of the diode is to prevent current from coming into this thing. And you know, here's the thing. If everything powers on at exactly the same time, you don't really have to worry about it. But you can't always guarantee that, and you definitely cannot guarantee it with a battery. So the reason you use the diode is because if you were to not have a diode in there and then you plugged your battery in like that, all right, and the ESC were turned off, then you're going to send voltage into the ESC, and that's bad. We don't want to do that. So that's why we use the diode. It prevents that current flow from entering the ESC. So if you want to use dual BECs, no problem. Just do the same trick, right? Instead of, if you don't want to use a battery and you just want to use one of these guys, just put another diode in there, and then you can go ahead and connect that to your mains power source, and you can provide power to your load via both BECs, no problem. Again, you want to make sure they're similar voltage. I don't think it's absolutely necessary that they're the same, because that's what the diode is for, right? It's to prevent the current from flowing. So if you had one that was 8 and one that's 7, I don't think it'd be a problem. But personally, I just wouldn't do that. For me, I would just make sure they're the same, right? Oh, and one other thing that I'll mention too, Dave and I had a discussion about this part. If you have a voltage system that is less than 8, you know, this everything that I showed you tonight assumes 8 volts or higher, 8.4 volts, right? Not every system is like that. Some servos are 6 volts. So if you're in that scenario, then you don't want to use a LiPo. You want to use something like an LiFe battery, right? And LiFe, they peak at something like 6.6. And when you factor in a little bit of voltage drop, you don't have to use a diode on a battery, because remember, you can charge a battery, okay? But if you want to get the exact voltage, you could use a diode to get voltage drop. Just remember, if you do that, then your BEC is not going to charge your battery. Just keep that in mind, okay? So it's just about understanding what's going to happen, right? You got to understand what's going to happen. It's about voltage potential, right? You got to make sure the voltage is married up on both sides, and that potential is near equal on both. And if that's the case, then, you know, you'll be good to go. So let's see. Other questions here. Robert says, I still have a whole bunch of those diodes from old Radio Shack that went out of business. There you go. So on an opto ESC, do you use 2 batteries? Yeah, exactly. You could use 2 batteries. Yeah, because the opto ESC, exactly. And in 2 batteries, remember, that's actually a good use case. And with 2 batteries, they are both designed to be charged, so you don't need to use a diode at all. As long as you start them near the peak voltage for each battery, and that's it. That's all you have to do. And they should peak. Like, you wouldn't want to use a 3S pack and a 2S pack together, but if you use 2 2S packs in parallel together, that's fine. You don't need a diode at all, because whatever, you know, basically they're in parallel. That's what you're doing. You're connecting them in parallel, just like when we connect flight batteries in parallel, and they'll both drain together. So yeah, with 2 batteries, you don't need a diode at all. One-way check valve. That's right. Doesn't matter, but higher voltage will supply the current. Yep, that's the idea. That's the idea. And so you know, it's not always the highest voltage though. I did notice a couple of times where the battery was feeding current into the system, even though it had slightly lower voltage. So I'm not exactly sure what the flow of electrons was there. Maybe the battery is being charged by the BEC at the same time. I just really am not sure. But yeah, that's the idea. It's the higher voltage potential that becomes the source of the current. That's the idea. That's exactly the idea. All right, guys, I think that wraps it up. I hope you guys enjoyed the content. If you did, make sure you smash that thumbs up button, subscribe, and hit the notification bell. Sorry about the goof up with the fan, but you can see it does work. So I'm glad it worked eventually. That proves the point. Thanks for joining me on a Monday night to watch this video on redundancy. And hey, you know, for 50 cents and a little bit of soldering time, you can easily add redundancy to your system. So, you know, if you got a plane that you want to keep and, you know, you want to make sure it's got that redundant power, I would do it. So I'm going to go tidy this one up and stick it in that ARS, 102-inch ARS. So I have redundant power on my next flight. That's all I've got for today. Take it easy and go fly something.